Welcome to our Sustainable House Day extension session on understanding EVs, home batteries, and the grid. My name is Sophie Weiner. I'm one of the organizers of Sustainable House Day as part of my role at Renew. So Sustainable House Day has run for 20 years. It's a national event organized by Renew, which aims to inspire people to live more sustainably through sharing peer-to-peer knowledge and experiences in sustainable housing. This is our very last webinar in our extension session series after our all-day event on Sunday, the 20th of September. We hope some of you had the chance to attend that day. So at this point, I just want to say on behalf of Sustainable House Day and Renew, I would like to acknowledge that this event is taking place on the traditional lands of the Aboriginal and/or Torres Strait Islander people. I personally am speaking on the traditional lands of the Wurundjeri and Woiwurrung people of the Kulin Nation. We acknowledge them as the traditional owners of this land and pay our respects to elders past, present, and emerging. We recognize that being a national event, we are each tuning in from different parts of the country. So we invite you to share which traditional country you're watching from this evening in the chat if you like. We would also like to extend our respect to all Aboriginal and/or Torres Strait Islander people, including those we may have with us on the panel or in the audience today. We thank them for their continuing connection to the land, waters, and community, which has existed for many thousands of years as the oldest living culture on Earth. We acknowledge the pivotal role that they have played and continue to play in caring for country across Australia. Sovereignty on these lands has never been ceded and treaties are yet to be negotiated. This always was, and always will be Aboriginal land. So again, thank you for tuning in with us tonight. In a few moments, I'll be handing over to your MC for this evening, who will lead the discussion and the question and answer session. If you would like to ask a question of the panel tonight, you can use Zoom's Q&A function, which you can find by moving your cursor to the bottom of your Zoom window in your toolbar. If you would like to react to something via text or share your own experiences tonight, you can feel free to use Zoom's chat function by clicking on the chat button at the bottom of your Zoom window in your toolbar. If you'd like everyone who is watching to see what you say, you can select all panelists and attendees in the drop-down box above the text field. Otherwise, if you just want the panel to see it, you can use the panelist drop-down. We do have closed captioning, live closed captioning for this event. If you want to use that, you can click on the button in the upper left-hand corner of your Zoom window that says Live on Custom Streaming Service, and then select View Stream and Custom Live Streaming Service to open a browser window with our live captions. I want to acknowledge that this event would have not been possible without the support of our Renew members and our sponsors. So now I will introduce Clive Atwater from the Australian Electric Vehicle Association, who will be emceeing tonight's event. Clive, you can turn your camera on. Hi, Clive. How's it going?
Hello. Hopefully my camera is on.
You
So is my
are.
mic.
You are. Hi. All right. I'll leave you here. You can take it from here.
Okay. Thank you very much, Sophie. And it's great to see a huge number of participants in tonight. It counts over 200. So it's terrific to have such a great response to this evening's session. As Sophie introduced me, I'm the Vice President of the Australian Electric Vehicle Association. We're a national organization with branches in every state and territory, and with a growing membership, growing very strongly. And we try and advocate for electric vehicles, but in particular, we're interested to see that they're done well, not necessarily in a hurry, and that means getting to grips with some of the technical issues that our panelists and people will be raising tonight. We've got three great speakers. I'm not going to talk for long. I'm going to leave them some time. The first one, we're going to have three speakers. They'll each speak for about 10 or 15 minutes. Then we'll have a Q&A session. Your questions you can submit during the Q&A or through the Q&A channel. We've had about 50 questions submitted before the event, and they will be answered, and that will be made available. I'll let Sophie give through the details at the end. We'll have the three speakers, then we'll have the Q&A, and wrap up around about 7:30. The first speaker will be Bryce Gaton. He's a writer, journalist, and consultant and educator with a keen technical knowledge on EVs and what's inside them. He's going to give us a background on EVs and charging, Bryce writes regularly for Driven and Renew. He edits the AEVA newsletter and develops fact sheets. He's also an EV safety trainer, supervisor at Melbourne University's School of Engineering. He is a very active member of the Australian Electric Vehicle Association. Our second speaker will be Glenn Morris. He's also an educator and consultant who's pretty much grown up with solar and knows the ins and outs of panels and inverters and increasingly now batteries. If you've had a solar system installed in Victoria or southeastern Australia, there's a reasonable chance your installer has attended one of Glenn's many, many courses or used his material. Glenn is so close to the leading edge in the industry that manufacturers send him equipment without him asking to have a look over and test it and trial it before it goes to market. So Glenn's presentation tonight has a very strong focus on batteries and issues around the safe installation of batteries in homes. Laura Jones is our third presenter with a strong interest in and experience in the grid and integrating new technologies into grid operations. Having recently left work with the State Electricity Network, Laura is now focused on a research project getting EVs better integrated into the grid and has some fascinating stories to tell us. So without further ado, I'm going to hand over to Bryce. Bryce, you can load your thing. You're with us. You're turned on. You're visible.
Yes,
good.
yes,
I'll let hand over the controls to you, sir.
Okay, thank you very much, and welcome everyone to the event this evening. I'll quickly share my screen if this works. Here we go. Oh, yes, here we go. Can everyone see that? I'm guessing they can. Today I'll run through a how and now guide to EV charging. So I'll talk about what's available currently, with the idea of the other speakers will talk about some of the links with this and the future of what I'm talking about and where it may be going, because some people will be interested in what's the future of EVs and using them as batteries rather than the moment they're pretty much strictly charging. So I better find the right button. First up, I have this bad habit of using a whole lot of terminology, and of course my slides have decided they don't want to. Oh, there we go. I always use a bit of terminology, and if I say PEV or FEV or HEV or even a FSEV, these are the terms that I'm talking about, and of course I will be running an exam on the end, so be prepared for at least 50% pass. On the left you'll see the plug-in vehicles. These are the ones that I will be talking about tonight. You're a battery electric vehicle, or BEV, and these are the ones that are, as you can see there, just have a plug and you recharge them via the mains or via a battery or via your off-grid systems. Then you have your plug-in hybrids, which have the combination of an ICE or internal combustion engine motor alongside the battery system, which is a smaller battery in this case because it can go a bit further than the ICE motor. As a consequence, they're a bit cheaper at the moment, but the predictions are that about 2024, the first segments of the market will be reaching price parity with their internal combustion engine cousins. And by 2028, all segments should have actually reached that stage. Anyway, they're a bit of acronym. Next one. We often talk about EV charging or EVSEs. Most people colloquially call them a charger, which I've given up on saying that the AC ones are not chargers. They're just a way of supplying AC power to the charger in the car. So if you look at what is your, let me see, left-hand side, you can see three types of EV chargers that you'll put on a wall or plug into an outlet. And on your right-hand side, you can see the two big chunky ones. They're DC fast charge, and they are true chargers because the charger is built into those big boxes, and they feed DC power, DC electricity directly to your battery, bypassing the charger. So for tonight's discussion, I won't really be referring much to the DC charging. I'm talking about AC stuff that it does with your home, except when it comes to vehicle to grid, and I'll explain why soon. Okay, first question is, how do I charge? Well, key point of difference to a petrol car is refueling paradigm is very different. When you come home with your electric car, you think of it as a mobile phone model. It's plug and ignore. You just plug it in, walk in the door. You don't have to find, stop, and act as the fuel pump attendant to your car whilst waiting for it to refill. First of all, you got to find the petrol station, then you got to stop, wait. Hopefully it's clear for you to get in. Then you got to get out, whatever the weather. So I find it, having driven EVs for some time now, it is so nice driving past petrol stations and just waving and going, no, need to go there. So just have to think about it. It is a different paradigm, which means there's a few changes to what we're used to. But I often say that I'm willing to bet the first horseless carriage owners pulled up next to a hay manger or something and wondered why the car didn't refuel themselves. So it takes a bit of time, but we will all get there with just dealing with it, and we'll all get used to it. So first of all, how fast can I charge? Well, it depends on what outlet they plug into and what charging system you're using. So if you plug into a PowerPoint, and I've just done these for a Kona, a Renault Zoe, and a Tesla Model 3 long range, it's slow, but it's handy. So if all else fails, you can plug into a PowerPoint if you're running out of charge. So much easier than trying to find a jerry can of fuel and not get fuel on yourself, get a lift to back to your car, et cetera, et cetera. Whereas this is just plug into the nearest power point. And there's probably tens of millions of them out there. So it's not too hard to find them. And as someone who's driven electric cars for about 8 years now, I've only run out once, and that was actually deliberately. I just accidentally did it a couple of k's short of home when I was trying to flatten my conversion battery, and it ended up flattening a little too early. Yeah, 10 amp power point is fine, but it will take a while. You could go up to the next one, the second line there, that's a 15 amp power point. That gives you 3.6 kilowatts. And for my Kona, I drive a Hyundai Kona, I jumped from 28 hours down to 18 hours. So that sort of number, this is from 0 to 100, by the way, so I have to be right empty. I can drive into a caravan park at 5 in the afternoon, and by 8 in the morning-ish, I'm ready to go fully charged. And that's what I did on my EV long weekend tour. September last year to prove when Scott Morrison said they'll ruin your long, was it not, Michaelia Cash said they'll ruin your long weekend because you wouldn't be able to get very far. I went, challenge accepted. So off I went around Victoria, did 2,400 Ks in 7 days, did not use DC fast charge. That was one of my rules. It was just, can I just drive comfortably, plug in at a caravan park or a hotel? And I did it comfortably. Or at least the car did it. I was exhausted at the end of it. 2,400 Ks as a long weekend is not what you would normally do. It was well worth doing though. If you're going to go up to the next level, which is that third pair of lines there, if you're charging at 7.2 kilowatts, my Kona will take roughly 9 hours. So if I'm starting to look at charging at an off-peak time, that 9-hour number, unless I'm fully down 100% down to zero, I'm probably going to get in that rough 8-hour time zone for a off-peak time. So we're starting to look good just for charging at home and using off-peak rates. Going down further, if you have a 3-phase car, they can do, there's Renault Zoe, for instance, can do 22 kilowatt charging. That would get fully charged in about 2 2/3 hours, 2 hours 40 minutes-ish, 2 hours 45, something like that. And the Tesla Model 3, again, it's quite a big battery, but it will also still charge in under 8 hours. So it could, in theory, and it, by the way, charges at 11 kilowatts, not 22. The Zoe is the fastest. If you're going for DC charge on the highway, I'll throw that in just for fun. 75, let's see, a 50 kilowatt charge, which is those sort of robot things like they escaped from, what's that film that was a while ago, the Lost in Space. They look a bit like that. It's they're built by Tritium. My Kona will do that in a bit over about an hour and a quarter. If it plug into the bigger chargers, my maximum limit in the Kona is 70 kilowatts, so I can't take advantage of up to 350. Not a lot of cars can, but some can. The Tesla Model 3 will do 250, for instance. It'll do it in half an hour. I do, by the way, put these little caveats on the side, so I'll flick through them very quickly. These are roughly worked out. They are not estimate. They're estimates. I spent a lot of time working them out and bouncing around with people, so they're pretty close. Always refer to the official paperwork put out by the manufacturers because they have a habit of changing things when I least expect it. Assuming, there's just a few assumptions there. Anyway, I'll skip through that rather than take up people's time. If people want a copy of this presentation, by the way, email me at the email address at the end of this presentation. I'm happy to send it out to you. Okay, how fast do I need to charge is the next question, because unlike a fuel pump where you actually have to charge or refuel at the speed it says, I can choose to charge at the rate I want depending on the price that's available to me. So if I'm doing less than 200 Ks in a day, the average commute in Melbourne or most big cities is about 30 Ks a day. So you can charge overnight, 2.4 kilowatts will give you comfortably less than 8 hours. So you could pick an off-peak rate, for instance, or you could plug in during the day using your solar, and it's a slow rate, but it would comfortably charge up. If you're wanting to put that PowerPoint in, a proper 15 amp PowerPoint, the one I'm showing there, because you have to put in a minimum 15 amp for EVSE charging, and it has to plug direct into the switchboard. It can't go via just an ordinary PowerPoint looping around the house. They're about $500 to put it in. It goes back to switchboard, a particular type of safety switch they have to use. I do make the point of these are not meant to be used for permanent or primary or sole charging method, because that's what can happen. You can end up with melted. PowerPoints are just not built for continuous high rate charging that an EV draws. So if you're going to be putting something in at home and charging it from home, put in a more dedicated thing like that one. That's a 32 amp that I put in for mine, single phase, because I only have single phase at home, and most people, that will give them 9 hours for a full recharge on a Kona. So that's what I put in there, 32 amps. So, and I do a whole presentation on choosing this and what sort of charger to put in, or what assessing a power supply, so I won't go into much detail. But if you've got a modern house, sort of less than 20 years old with room in your switchboard, you can pretty much put in the full 7.2 kilowatts. If it's older than 20 years, then you may have to start assessing it. But again, you may not even need 32 amps, 16 amps. If you're only doing a couple of hundred Ks in a day, 16 amp charge or 3.6 kilowatt would comfortably see you charged overnight. So why would you want to upgrade your switchboard and everything else if you could put a lower power EVSE in anyway? Putting one of those in, it's roughly $1,500 up, including the EVSE and itself. A basic EVSE will be fine. Okay, looking at maximizing your monetary savings. If you want to choose the right tariff, so if you're using off-peak overnight, for instance, or during the weekend, you can see you can choose your rate of charging, so the speed of charging, and then we look at, okay, if we put it on a lower tariff, nice and cheap overnight, for instance, compare it to a petrol car, and that's your average of 8 litres. I think the average car in Australia, petrol car, actually is 10 litres per 100 kilometres from memory from the Bureau of Statistics data. So I was a bit generous at 8. Renault Zoe at 130 is probably one of the lower ones. Oh, it's not too bad compared even to a Kona or a Hyundai Ioniq or a BMW i3 even, or the Tesla. So they're all lurking down around 1.5, 150 watt hours per kilometre. Anyway, I'm babbling. At that rate, you're spending $332.50, not to be too specific, on fuel for the year to do 10,000 Ks. Your petrol cars just run $1,200. So your savings already, plus you've servicing savings. So you're looking at, for every 10,000 Ks, you're possibly saving a bit over $1,000 per year. So that's, if you're looking at purely from the monetary side, EVs do pretty well, and it's a matter of choosing your tariff and your connections. And that's something that Glenn will speak a little more about, I hope, in the next slides. On the other hand, if you want to start looking at saving carbon dioxide or carbon dioxide equivalent, so it's all your greenhouse gases, this table is done from the Department of Environment's own data and according to the international protocols for it. So what's the word? Craig Kelly, eat your words, because this is the actual data from the government department using the government's own methodology. To quickly run through it, if I've got a Toyota Corolla 2017, that was new when I did this article, which is written in Renew for those people who've got the article, just about due for an update actually. You're putting out roughly 2 tons of carbon dioxide equivalent for the year for 10,000 Ks. If you drive that same car, which is a BMW i3 equivalent, so the Corolla, you're putting out 1/4 of a ton. So it's a huge difference. And as you work up, South Australia is about 50% renewable, so it's about 0.8. In Victoria, even with our horrible, dirty brown coal, it's still 1.64 versus 2 tonnes if you're driving around town. The only situation in the whole of Australia where it's worse, and it's only if you're charging off the grid and nothing else, is that 1.64 number. Slide across to 1.55 there, so you're about 5 or 6% over, but that assumes you don't use solar, don't subscribe to green power. So there's only one scenario if you really want to fudge the figures that you can end up with more, but only slightly more. In my case, I have a solar system, so I would be knocking that down. I haven't bothered doing the calculations. Anyway, using those numbers, if you're going to be minimizing your carbon dioxide equivalent with solar panels or with batteries, as Glenn will talk about a little sooner, a bit later, you would be charging during the day instead of your night. And basic system, just using a dumb EVSE, you just set your car to a lower charging rate. Most EVs will actually allow you to charge, or if you're using a plug-in charger, a lot of those will set you a lower rate. More advanced, there are EVSEs or EV chargers available that will actually monitor your solar output and move the charging rate up and down to suit. So you can say, I want 100% solar, so it'll just charge at whatever the solar's putting out. If it's 50% solar, it'll balance that way. The Zappy is one example of that one. You could, of course, use home storage battery to store during the day and charge the car at night. I'll leave that one to be talked to by Glenn. Vehicle to X, I'll talk about them a bit more in a moment. They're the next slides of what's available now, and what's coming will be coming or discussed by Laura. So Next slides, vehicle to X. I think a lot of people have seen that. What's vehicle to X? Well, it's a combination of V to H, which is vehicle to home, which is your stuff behind the meter. So you're just using the car to power your house, but it doesn't go to the grid. Vehicle to grid, V to G, which is what everyone does talk about, is you can actually charge the car from the grid, charge the car from your solar, and put power back to the grid later on. And there will be, like a solar system, you can actually feed power back to the grid at other times. And V2X is sort of a general term for one of that. You can be either of those. This, by the way, is done by the DC connector, not the AC connector. So one of the minor hiccups with this type of system is you'd always have to drive home and plug it in to take advantage of vehicle to grid, because your battery is rolling away from the house every time you unplug and take it for a drive. As I do point out, if you're waiting on that battery system to be your backup system, if you go away for the weekend and your car's with you and the power fails, your fridge will still defrost. Currently, only CHAdeMO, which that picture there is of the Nissan Leaf 2 ports. That one on your left is the CHAdeMO port, and that is the only system at the moment that will do V2X, but they're not approved for use here. There's some trial systems, like about 50 being done in ACT. Laura will know more about these. She may mention them, but it's not approved for general public install yet. CHAdeMO, which I just talked about, is, however, on the way out. CCS, combined charging system, that's a picture of my Kona charging there, is becoming a dominant DC connector. Even Nissan is giving up CHAdeMO outside of Japan, starting with their next EV models. So CCS is being developed to do vehicle to X, and it's not too far off. And I'll put a slide up next about that. So the outcome of this is roughly around 2025, you'll be able to do V2X of various sorts. Your systems and your hardware will be approved and available here. Until then, it'll be a little bit of waiting. I've thrown this up. You can read it or not as you will. This is the roadmap that Charin, which will look after the CCS protocol, have set out for getting from charging the car now, so that's the one on your left, right up to full V2G bidirectional, so you can charge in or out of the car, delivered to the grid, charge from the grid, be controlled by the grid. That they're saying that's 2025 or there, or a bit earlier, perhaps some people are saying. But that's their roadmap. So there is a roadmap for the CCS system. It's a little bit behind CHAdeMO. There's a long story attached to that why, which I won't go into here. But CHAdeMO just happened to get there first is probably the short answer. But CCS is not far away, so the vast majority of cars around 2025 will offer that capacity. Okay, if you want to find out some more, join us in the Electric Vehicle Association. We charge the enormous sum of $50 for an individual, or $25 for your concession rate. Or if you're a business member, say a car dealer or one of the EVSE suppliers, parts suppliers for components, for conversions, that type of thing, please join us, $125 for a corporate member. If you're looking for information, the quickest way to go for that is we run 2-page fact sheets on all the battery electric vehicle models available in Australia, and I'm the one that writes them, and I add them as the models become available. And there's also a full list of the prices and specs of the plug-in hybrids as well. But I don't do sheets for just the REVS. There's just too many for me to keep that going. Also, I'd like to announce that we, AEVA, are doing the EV Vision e-conference, and it's on the 27th of November. If you really want to find out lots more about what's happening, it will be the biggest EV-only conference ever to be run in Australia, having a full day, 45 speakers, 3 streams. There'll be an intro and plenary. The intro will involve Tim Flannery, the environmentalist, as well as the Victorian State Minister, doing hopefully some very interesting announcements about what Victoria want to do about electric vehicles. There's a roundtable of international electric vehicle associations and discussing what they do and how they've supported it. The whole point is trying to learn how they do it over there and what we can do here to do a better and better job of getting the EV transition happening. If you want to go, yes.
I think we're going to have to wrap you up at that point. I know you've got some more information slides.
Okay, I'll just put that up there.
Sophie's been feeding those through. Sophie's been feeding those through to the viewers, so they'll pick up on that information as well.
Beautiful. I shall unshare. Stop sharing. The screen is yours.
Thank you very much. And at this point, I'll introduce Glenn to come on and follow up with some of the points that Bryce has raised on the side of the batteries. So over to you, Glenn.
Thanks very much, Clive, and thanks Bryce, for one of your excellent presentations. In fact, you basically encouraged me to get an EV, so thanks for all this information in the past. I think you've overpromised a bit on what I'm delivering today. I'm actually focusing a lot on where you can install batteries, because it's really interesting times. I looked at a lot of the pre-questions that came up in the list of questions before this event, and a lot of it was about batteries in people's homes associated with EVs to basically capture solar energy and allow you to utilize that, particularly for vehicles that aren't at home when you want to charge them. So capturing that solar and then using it to charge your vehicle. So I'm going to just run through a few scenarios around where you might install a battery, but I've got some good news straight up, which is the new Australian battery standard doesn't affect EVs, because EVs actually have their own standards. So a lot of this is only about residential storage, not the EV. You can park your EV in the garage. Whether you can put a battery next to it is a big question, and that's what I'm going to answer for you. So let me just jump into my presentation. I run a training facility called the Smart Energy Lab, and as Clive mentioned, I do quite a bit of testing of products. At any one time, I've got something like 20 solar inverters and battery systems running along in my labs. And that means I get to be exposed to a lot of the technology, the pros and cons, and the configuration challenges with that. So at the moment, I'm running online courses because I can't really have face-to-face courses. I've lived off-grid almost all my adult life, and this is actually where I live in the Yarra Valley on Mount Tillabong, and it's where I do all my training. And that's my community. So there we go. We're in a transition towards an EV lifestyle. So we've actually put in EV supply equipment, as Bryce rightly mentioned. It's not a charger, and we're basically open for people to use it as a community service. But I'm going to focus very much on the practical side here in terms of installing batteries and where you can put them. So I'm going to run you through a little scenario of how these systems can work. So let's look at the standards. The standards now, I'm not going to give you lots of slides with lots of words on them. It's not my style. But this is about the only slide with a lot of words on it. And it's from the new battery standard that was published last year. And it lists a whole bunch of restricted locations. Now, I'm going to go through with pretty pictures and drawings and explain these, but that's just for the purposes of a record with this presentation. This is the actual wording that you need to comply with. So let's look first at where you can't install equipment associated with a battery storage system. Now, a battery storage system, sometimes called a BESS, battery energy storage system, which is an integrated solution. Think, say, Tesla Powerwall, Sonnen, Alpha ESS, something that's a pre-assembled solution that you can put it install as a completed system. There is a restriction on what's not allowed to be next to it. You can't have, for instance, a hot water service, a gas bottle, an air conditioner. There's a whole bunch of appliances that can't be within that zone. So this is going to sort of like push away appliances from where your battery system is. The logic behind it is about if this system were to fail, that it doesn't take out other services from your home. You don't lose your NBN, your hot water, and your aircon at the same time. Now, I'm going to draw some little pretty pictures here and just show how this all works in terms of exclusion zones. Right, so let's get my mic a bit closer. So this is a house, and the house is made of brick. Now, being brick, it's deemed to be a surface that is a fire barrier to the home. And that means that if you've got rooms that are habitable behind that wall, you've already got a fire barrier. You don't need to have any other protection, but you do have some exclusions from other entrances to the building, such as windows and doors. Now, it might be a little bit hard to see, so I'm just going to make it a little bit brighter with a black pen. So 900 millimeters above and 600 millimeters either side. No windows, no doorways, and no vents that vent into the building. So your battery system has to have a little bit of clearance from where, if it were to fail, doesn't ingress toxic fumes or any fire materials into the building itself directly. So the brick wall is the key thing here. Now, it's not just brick, but it could be concrete, it could be cement sheeting. It could be a material that's fire rated. There is an Australian standard for fire rated materials, AS 1530.1. Any of those would be deemed to be a fire barrier. But you only require that fire barrier if there is a habitable room behind that wall. But you still need to have that exclusion from openings into that building. So let me just bring up another page. Here we go. This is real old school slides. They're actually bits of paper that I draw on because, I don't know, I'm an analog sort of guy. So here we've got a house that's made of weatherboard. And being weatherboard, it's actually quite a combustible material, certainly if there is a fire. So now you do need a fire barrier if behind it is a habitable room. Amazingly, you don't if it's not a habitable room. So what's not a habitable room? That would be a garage, a storeroom, a utility room. Those are deemed to be non-habitable. The National Construction Code lists what's habitable and what's not habitable. But let's assume there's a bedroom behind this wall, and therefore we are required to have this fire barrier. Now, the fire barrier is listed as a bunch of materials similar to ones I just listed for the wall. It could be made of brick, terracotta tile, cement sheeting, or a material rated to AS 1530.1. From experience, what's most popular is actually using a cement sheet. Well, a couple of them possibly. And depending on how wide your battery system is, yeah, it might be a couple of sheets up on the wall to protect that surface in case of a fire. If the eave of the building, so if this distance between here and here is pulling down into this zone, so if your roof was like here, you don't have 900 millimeters above the battery system, you actually need to line the eaves of the building as well, or the ceiling. So that really could have an impact on the ease of installing that system. So I'm afraid some of this is kind of bad news, but remember this only applies to this only applies to batteries that are installed as a fixed installation and only to residential installations. So it's all about habitable rooms. There's another set of guidance for commercial and industrial. So the last slide here is just a corner case, excuse the pun. So that 600 millimeter rule actually wraps around the corner. Now, if this was a lounge room on the corner of this building and there is a habitable room behind and the surface of the wall is not deemed to be a suitable fire barrier, then you are required to extend that fire barrier around the corner to 600 millimeters and still maintain a distance from any window or door of the same. So I often say if you're choosing a location for a battery system in your home, you're going to have to get out a tape measure and have a walk around and measure all those clearances. So I'm going to give you some practical examples from my own home. I did a walk around and tried to work out where I might put a battery system. So let's have a look at those. Haha. It's actually not my home. We'll get to my home in a second. I just wanted to point the difference between what's often shown in fancy advertising photos and what the reality is under our new battery standards. So this is a lovely promotional photograph from Tesla before the standard was published. Now, if that wall was, say, cement rendered foam, so it's a super high insulating wall, it's not deemed to be a fire barrier, and that is a lounge room behind it. So they're definitely going to have to do something about protecting that surface from the spread of fire. So what happens when we apply the new battery standard? We end up having to put some cement sheeting around the side there and behind it. And I actually have to move the pot plants. If I go back a slide, you watch the pot plants move. There they are there. We've got to be 600 mils from the window. From the sliding door, so we push it over a little bit like that, and there we go. So that probably added a bit of cost, but we also got quite a few mandatory signs that need to go in, such as, if there's any risk of toxic fumes, and there's a whole bunch of signs actually. I just pulled out one to give an example. So there's those clearance zones again that will be required to install that system. I'm not saying you can't do it, it's just you've got to consider these when you're trying to find a location for a battery system. So let's look at some examples from my training lab and some of the practical exemptions that you might come up with. Now, one is that if the battery system is more than 300 millimeters from a wall that has a habitable room behind. Now, this picture is not quite a correct application because it's an indoor battery and there's no habitable room behind. It's just outside. But imagine there was a lounge room or bathroom behind that wall. If I'm 300 mils away from it, I don't require that fire barrier. So actually, it's an incentive for freestanding battery energy storage systems that can be just plonked on the ground and don't have to be attached to the building. It gives you a little bit more flexibility. Here we've got, this is the back of my house, the south side, and this is a Alpha ESS system that my students installed probably about 3 or 4 years ago, actually, about 3 years ago, before the battery standard was published. And we've got a bathroom behind there. It's a habitable room. A point to note, though, that the window is a fixed window. It doesn't ventilate. So we actually don't have to stay 600 mils away from that window. It's a straw bale house, so please no Three Little Pigs jokes. That means I need a fire barrier behind that system. So I'd have to extend 600 mils either side and cover half the window up with cement sheeting. So this location, it could be done, but I'd probably have to shuffle the whole thing a little bit to the right to make it clear that window. If I think about the eastern side of the house, it's a driveway, and also it's got lots of windows. You can't put a battery system under a window if it's less than 900 mils from the bottom of the window, so you can't put it underneath any of those windows, can't put it within 600 mils of the edge of a window, and of course, if it's a driveway, you've got to protect it from mechanical damage as per our wiring rules, so probably bollards, which would make it impossible to get the car in. If I look down the south side of the house, you have to have clearance of 1 meter in front of a battery system if it is a path to exit or an evacuation path. Now, basically, if it's your front door, your back door, and you've got to walk past your batteries, you need 1 meter of clearance in front of it. Now, if the batteries are obscuring or obstructing your exit from the building by less than 1 meter, then it's not a suitable location. Let's look down the western side of my house and also the other south side. There's a lot of equipment on the south side of most homes in the southern hemisphere because it's the cool, shady side where people don't tend to have a lot of action going on. They put all their equipment there because it's cool and shady, and so I've got a lot of things: hot water services, inverters and stuff, gas bottles. So there's really nowhere else on the south side. On the western side, underneath that solar shade device, there's a few locations along that wall, but not within 600 mils from a window, not under a window. So that's a little bit of a limiting factor. If I think about an evacuation path, now obviously this is a freestanding house. There's plenty of room to walk around it. But if that was a fence on my right-hand side, I would have to ensure there's a meter clearance to get past it if it's an evacuation path. Coming around to the north side of the home, I say nothing to see here. That's basically because most homes with a northern aspect will have a lot of living space to the north, windows, entertainment areas. There is nowhere on the northern side. You might think, what about the roof? Well, actually, it says batteries cannot be installed on a roof unless specifically designed. Don't worry, Clive, I can see the time. And just to finish up with suitable locations, I made this little chart here to show you locations for an all-in-one system such as a Tesla, a separate lithium battery and charging device. Here I've got SolarEdge, LG Chem, or a lead acid system. Lastly, you need to consider the external temperatures. If you live in a cold zone, well, I live at Mount Tulibuwong, which is 700 metres above the sea near Melbourne, and it freezes. That's just last winter. So a lot of lithium batteries really don't like the cold. Anyway, my time's up, and back to you, Clive.
You're a real pro, Glenn. You've got it down pat, and you hit the nail on the head. Good man. And a very practical man, as we can all see. Lots of very useful information if you're starting to think about a battery for home. Things you need to know right there in front of you up front. Didn't get into the performance and the cost and all that side. I'm sure that's going to come up in the question and answer. We got time for that as well. If we move forward quickly, Laura, it's your turn. You ready to roll?
I am ready to roll.
Take over.
My screen. None of this fancy drawing stuff from me, sorry. Thank you very much. I'm Laura Jones. I would like to begin by acknowledging the traditional custodians of the land on which we meet today and pay my respects to the elders past and present. I extend that respect to Aboriginal and Torres Strait Islanders people here today. We are across Australia, as was said at the start, but I'm on the land of the Nuinina people here in Hobart in Tasmania, and I'd like to pay my respect to their elders past and present. As Clive introduced at the start, I'm Laura Jones, and I am from the Australian National University. And I'm a small part of the REVS project, which is a EV V2D demonstration project happening in the ACT. So we do have first-hand experience of trying to get V2G chargers approved in Australia, which is a rather long and complicated process. Today I'm talking about smart grid. So what is smart grid? Why would you want to do it? And where we are at the moment. It will have an EV focus because that's the project that I'm working on. And I guess a bit different to the other presentations, which have all been quite practical. Mine's more focused on the future and what we might see coming in as utilities and as the industry picks up smart grid a lot more commonly with these reforms that we're seeing in the energy industry at the moment. So maybe I might start by talking about what smart grid is, and the best way to explain that might be to talk about what an unsmart grid is. So traditionally, we had a grid that you might call unsmart. Energy and information would generally flow in one direction from centralised generators through big poles and wires, down to small poles and wires, and down to customers at the end. I worked in a distribution network until quite recently, so we looked, well, transmission and distribution, so we looked at the two different sorts of poles in the middle. And particularly in the distribution network, it was often very, very low tech. A lot of information, there wasn't a lot of information on how the network was built, how it was configured, which made a lot of things quite difficult. But all of this was sort of designed by engineers who made fairly technical decisions about big central assets that had high reliability and complex controls. So it was all very, very centralized. But things have begun to change of late. In the smart grid, we've had digital technologies and IoT start happening. We've all got smartphones. We all expect things to happen at our fingertips a lot more often, which has been quite hard for utilities to do when they only read your meter once every 3 months. So they can only tell you what happened 3 months ago. The rise of PV has made power flows two-directional. We set another minimum demand record in South Australia quite recently, about 360 megawatts, which is very, very low. And we're sort of getting this, what happens when we have actually got no net demand in in states like South Australia, which is an interesting challenge to manage. And now we've got EVs that have come along, which is new demand, but also quite flexible. So smart grid's really all about navigating this change. It's about these 3 Ds of decentralisation, democratisation and digitalisation that's sort of coming at the moment. So maybe what I might do now is quickly explain the logo as probably a smart grid project. So what we're doing is very much what you could say is a smart grid project. Our project is about electric vehicles providing services into the grid. So it's a demonstration of vehicle to grid. We've got 51 vehicle to grid equipped EVs, 50 of them are in the ACT government fleet, and one of them's in the fleet of ActuAGL, who's a retailer in the ACT. And then we're doing one thing with those vehicles. So we're demonstrating contingency frequency control, which is really about what happens when you've got a big fault in the network and you've lost a generator or you've lost a load. They're really providing response to try to manage those sorts of faults and help the grid ride through it. There are 6 industry partners in this project, and you can see all their logos at the bottom. So we've got Evo Energy, who's a network. We've got ActuAGL, who's a retailer, ACT Government, JetCharge, Nissan, SG Fleet. But the other thing about this project is it's about a model of the future. Our role in the project at ANU is really about trying to take this from 51 vehicles on one service to 50,000, 500,000, 5 million vehicles in lots of different sorts of services. So what would you need to do? What are the enablers? What are the blockers? What are the technical and economic and social things that you need to consider? This is an ARENA funded project. So ARENA put $2.4 million toward this $6.26 million project. This project's recently started. So mostly at the moment, we've been trying to work out what else is happening around the world in this space. So I'm going to focus the rest of this presentation on basically examples from around the world, the various other smart grid things that people are doing. At its crux, really smart grid's digital technology that allows two-way communications with people. So to someone who might be a participant in a smart grid sort of scheme, it looks like a utility is suddenly wanting to be your friend so they can convince you to participate in the grid. Or maybe it's about utilities saying, I'd like to control this DER, this solar or EV that you've installed at certain times because we need to manage some issue in the grid. And I'm going to focus a bit on what this looks like for the end user, what it looks like once it's gone through into a product that you might be able to buy. So we can start locally. Some of you might have seen AGL's recent product. It's an EV subscription service. So for $299, you get an EV, you get insurance, you get maintenance, you get charging, all of that sort of stuff. But you also get smart grid participation. When they're talking about we'll also manage your charging station, it's really about them managing your charging to minimise the cost, what it costs them to supply your EV with energy, or to supply themselves, or manage their generation fleet, or whatever it is that they want to do with it. So for example, it might be about charging when energy is cheap in the grid. It might be about charging when they've got excess wind energy that they'd like to consume, or when the network would like less demand in the particular area of the grid that you're connected to. In theory, at least, this looks like a lower subscription cost, although AGL hasn't told you exactly how much buy in this particular product. These subscription services are actually quite common worldwide. In the UK, there's another one by an energy retailer called Octopus. This one is actually a V2G product. So for £225 a month, whatever that works out to be in Australian dollars, you get a Nissan Leaf, a 40 kilowatt hour Nissan Leaf, and a V2G charger. If you plug it in at least 12 times a month when they'd like you to, you get £30 off the lease. So as much like the other one, this is also a smart grid type product. Octopus Energy have a bunch of interesting products. They're probably one of these, hip new retailers in the UK. And they do have a dynamic pricing product, a bit like Amber does in Australia. So at 4 p.m. every day, they'll give you a forward 24-hour price of this is what your energy is going to cost every half an hour for the next day. They've also published an interesting report on their website that showed the response they got from a bunch of EV drivers who had picked this particular product to the signal that they've given customers. So this is really about how EV drivers have altered when they charge their car to reduce their cost to charge. The red line in this graph here is what their consumption was like before. They had this signal to charge at cheap times. And the green line was after, and you can see there was quite a dramatic change. Recently, the Australian energy retailer Origin Energy has invested $500 million in Octopus. So you might see a few more of these sorts of things happening in Australia. But I am using the UK a lot in these examples. And it's partly because in the UK, networks, so the transmission and distribution networks, have picked up flexibility a lot more strongly than they have in Australia. Basically, all of the networks in the UK have said that when we've got a problem in our network, we're going to try and solve it with demand response before we go and build a new network. So this has created the demand for products like Octopus. Really, an electric vehicle is not a generator. It's really a means of shifting demand around. So shifting demand from expensive times into cheap times, or times when there is constraint into times when there isn't. So this creates a value stream for products like Octopuses and all of these sorts of ones that make them work. In fact, UK Power Networks, which is the network that covers London and the surrounds, did a tender for demand response services, and they procured about 120 megawatts, and about 65% of that came from electric vehicles. So these sorts of services are quite common in the UK, much more common than they are here. The question, I guess, is that once you're inside these sorts of products, what does it look like to be a part of it? There's another product in the UK that's from a retailer called OVO. This is another V2G trial. And in this case, what they've done is framed these benefits up as a feed-in tariff. So you get 30p per kilowatt hour of energy you feed into the grid if you don't have rooftop solar, and a little bit less, 26p if you do, because they can't control the solar component of your feed-in. Consumption rate's about 15p per kilowatt hour, so it's about twice the consumption rate for energy you put back into the grid. But the reason I wanted to talk about this one was because some participants in the UK version of EVA have made some interesting videos about what it's actually like to be a part of this trial. And what was surprising to me when I looked at their video was exactly how much energy was going into and out of these car batteries for grid services. This is a little table here that shows, it's a screenshot from the video, the link is in the bottom there, that shows the amount of energy that's come in and out of this particular customer's car due to participating in this OVO scheme. And you can see that 63% of the energy that went into the car came back out of it again for grid services. Noting that some of these months here will have impacts due to COVID because obviously they couldn't drive very far. But you can see the months at the end of 2019 were much the same. A lot of energy that went into the car came back out of it again for grid services. I mean, this isn't necessarily a bad thing depending on what in particular you're interested in as a customer. For this particular person, they've essentially wiped their electricity bill completely. They tend to average a small credit on their bill because of participating in this particular scheme. Currently, a lot of these things are in the future. V2X, V2G is very much in the future in Australia. Chargers are hard to get. We are going through the approval process for the charger that we're using in our trial, which is a product called the Wallbox Quasar. So hopefully soon that will be available. But they're also very expensive. It's quite hard to justify them on their economic grounds alone because the cost is so high. And I guess once you've got the charger, the fact that these products that are quite common overseas are not particularly common here in Australia at the moment. You can see more of this stuff happening in the home battery space with these VPP products that you're seeing in South Australia. You've got the Tesla VPP, you've got Simply Energy, and a bunch of others that are sort of popping up that are doing much the same thing with home batteries, noting that they are quite hard to install, as was talked about earlier. But these things will come. Australia is in the middle of a transition with the rise of PV, the closure of coal. There's all of these questions about that utilities haven't really had to answer before. What happens when rooftop PV meets all of demand? How do you manage the system when much of your generation can't currently be controlled? How do you get the useful services like inertia and fault level you used to get from synchronous generators, from these asynchronous generators that are sort of being installed at the moment? The grids have become much more unpredictable, and grid operators are trying to work out how they deal with all of this. And there has been an impact in the market already. This interesting graph here, or at least interesting if you're a nerd like me, is the market price in Queensland over the past few years. So the black dash line there is the 50th percentile price, or the median price. So the price is above that half the time and below that half the time. And the grey area there is how much that varies. So a wide range shows lots of variance and a narrow range shows not much. So you can see between 2009 and 2019, the market price has approximately tripled. It's gone from about $20 to about $60 per megawatt hour. But also the variance has increased a lot too. And these smart grid products, they really make money from this variance. As I said, they're not a generator. They charge when electricity is cheap and discharge when it's expensive. So these sorts of things make these products stack up a lot better. This project that I'm in, REVS, is a small piece of this transition. It's a demonstration which hopefully leads to these things being more common in the future. A key part of our work is talking to people about what's interesting to them, about what's important to them. I've got the email address of my colleague, Kat, who is the social researcher who's on this project, and she will be really interested to hear from you if you would like to talk about EVs, V2G, or smart grid, or any of the things that relate to that space. And maybe, I guess, hearing all of this, maybe it's worthwhile doing a sort of quick poll. If you'd like to put in chat or question and answers, do you see yourself as a smart grid participant? What would impact your decision, or what would be the factors that would be important to you in deciding if this sort of product was for you or not? And where's Zoom gone? There we go. Thank you very much. Hopefully we've got some time for questions now. Well, I do note it's 7:54.
Yes, well, I'm sure we will. There's certainly been a lot of questions rolling in, so I might ask all of the panelists to turn their video back on so we can see you. And look, we've had so many questions. There's been a lot come through that have been answered on the chat, the Q&A chat. That stream will be available to participants, so you can see not only the questions but also the answers. What I'd like to do though is to pick, we've had a whole lot of stuff come in. We're not going to answer them all, we haven't got the time, but there's a few big trends or big themes that I'd like to address. The first one is really that question about price trends and availability. When are EVs going to be price comparable? When are batteries going to be cost effective? When will vehicle to grid, vehicle to X make sense? And I think I'd like to ask each of the panelists in their own sphere, probably Bryce on the EVs and Glenn on the batteries and Laura on the V2X. What do you see as the time, the future, how this might unroll over, let's say, the next 5 to max 10 years? Bryce, you first.
I'll start off with lots of forecasting houses now. Bloomberg New Energy Finance, for instance, predict a 2024 to 2028 sort of range for EVs to be moving into parity and then moving below the price of ICE beyond that, because they are cheaper to build once the battery price comes in. They say the price for parity is, I think it's $100 US for the battery pack per kilowatt hour, something like that. And there's another one, the Tim Storer's report, the Senator said, Tim Storer actually came out with those same numbers starting around 2024 for the Australian market, which would be the SUV market. So it's not long off. COVID may slow that a bit, but it's inevitable.
Just to be clear, that's the purchase price, isn't it? You talked about the savings.
Oh, the savings already, yes.
So there's a time before then when the purchase price is close enough to a conventional vehicle that the savings on fuel and operating would make it attractive.
Yes. So if you're keeping the car, say, for 5 years and doing 10,000 now for only $5,000 more than the equivalent.
Okay, Glenn, give us your take on batteries. How do you see them developing? Are they? Would you say they're cost effective yet? When do you see a timeline when you think they might be? And I know there's a lot of variables here, so.
Yeah. Actually, I'd like to talk about the EV too, which is so. I've had my internal combustion engine car for 20 years. It's time to buy a new one. It's done 800,000 kilometres. I think it's done its job. So purchasing a new car for me, I have surplus renewable energy, lots of it. So why would I ever want to buy another ICE? So for me, it's just a no-brainer that the next car is an EV. In terms of the affordability of home energy storage, at the moment, the paybacks are around the warranty period, so around the 10-year mark, and that's if you cycle the battery every day fully. So you wouldn't choose a battery storage system for your home at the moment just to save money. I'd probably recommend just put in lots of solar, as much as you can fit. That will save you a lot in electricity, and of course you can divert some of that by scheduling it to your EV.
And I think that's a key point, that the VV is the battery. If you can use the surplus when it's available, that depends on your lifestyle. You got to be home when the sun shines, or your car does. Laura, what about that V2X? Is that, it's tantalizingly close. It's happening in Britain. Is that for real? And something else I'd like you to bring up, and that is the effect of, because it's been asked by our viewers, the effect of frequent cycling on an EV on the lifetime of the battery.
Yep. So yes, it is more common in the UK, but most of these products that you see, particularly with V2G, are trials, which means that the cost of the charger is effectively subsidised through the fact that it's a trial. At the moment, they're very expensive, and that's probably mostly related to they're not a particularly high volume product. There's not a lot of them made, so they haven't really had the economies of scale that you see from solar inverters and things like that these days. That will change as these things become more common. And I guess at the moment, the manufacturers have got to look at the fact, well, if CHAdeMO is the only thing that offers it, and even Nissan have said we're not going to do CHAdeMO anymore, their market's not very big. So until you start seeing CCS V2G, I think they're probably going to remain expensive. The use cases where they may make more sense, they can, I'm pretty sure the ones that we're getting can do backup, which means that you can provide some energy from the battery, and you can get particular ones that do provide backup by themselves, so they can discharge from the CHAdeMO port. And at the moment, the economic returns, assuming that you can find a product that will let you participate into the market, which there isn't very many of them of, the economic returns do look fairly healthy. But there's a comment in chat that I've seen here from Campbell, which is on the point of if you look at what these big batteries in South Australia are seeing in their economic returns, most of it's coming from frequency control, which has been a fairly boring and esoteric service for a long time. But at the moment, it's worth a lot of money because there's not very much of it. But what happens is everyone's seeing this benefit and they're all jumping in and building giant batteries. And the market's not very big. So you'd expect in a few years' time, those returns will drop quite dramatically. So there is a whole bunch of risk in market participation as well, I guess, is what I'm saying there. But in the short term, I think you're more likely to see managed charging type products where you're not discharging the car, you're just simply choosing when you charge.
Yes.
For when electricity is cheap. And they're quite common and essentially off the shelf in a lot of places of the world.
Yeah, they're common and cheap. So the Zappy is the same price as anybody else's charger, but it will control your solar load into your car.
Yeah, and
for
it
example.
happens a lot in a lot of other countries too.
Yeah. What about the cycling question? If you use your battery for storage at home and like that, those UK numbers where 2/3 of the power is going back, the car is being used as a battery, not as a car. Well, as a car as well, but is that going to affect lifetime on warranties? And
yeah, so Nissan do warrant the battery for V2G, assuming that you use a charger that they've approved, which the charger that we're using is. So from a warranty point of view, it's okay. Interestingly enough, the second half of that video I showed the screen cap from was this particular person taking their EV to the shop and checking what the battery degradation was. And I think it was somewhere around 1% over the year that they'd had it with all of that transacting going on with the battery. One of the advantages, I guess, of the lease products is battery degradation is not your problem, in the fact that if the battery degrades, you give it back to the person who gave you the car and they give you a new one.
Yep, very good.
Which does help control
good
that
tip.
risk.
Another topic that's come up with a lot of questioners, and it's been presented in a whole lot of different ways, but I'll throw it out in general. I'll probably throw this one to Glenn, and that is EVs and off-grid systems. What are the issues?
Well, your ability to charge your EV would be a big consideration. The grid is basically an infinite source of energy. It's only limited by the capacity of your main connection to the grid, whereas when you're off-grid, you've got an inverter that creates its own AC waveform and often has much less capacity. So your ability to charge rapidly your EV is the main drawback, unless you have a very large system.
Okay. Any other comments? Bryce, have you had much experience with that area?
Sorry, I was just typing up an answer in the chat to someone. So what was it? Was to do with batteries and EVs? Yes.
Off-grid.
Off-grid, yes, off-grid systems. It depends on how much headroom you've, as Glenn would know, as how much headroom you've got with your solar panels and your batteries, as to whether there's room for charging the car, because the car is more load, more battery space. And also, if you're trying to trickle charge an EV, the minimum charging rate is 1.44 kilowatts. So if your solar has a lower output than that, like my solar panels is only an old 1.2 system, which I designed during Glenn Morris's class in 2008. Still going well. Anyway, that's it wouldn't actually put enough power out to actually charge it at the lowest rate. So
that's an interesting question. It's one that's been asked too, and that is, what if you bought an EV and you've already got solar panels and they're about right? How much more do you need to cover the car?
I could start answering that, and Glenn
Yeah.
will do it from the off-grid perspective. We say for on-grid, a 4 to 5 kilowatt system for a low end or an energy efficient house is enough to run a car and a home. For an off-grid system, that's obviously you've got to be sized for cloudy days and all sorts of things in your batteries. But that's sort of the rough number that I talk about. Glenn?
Yeah, I think your headroom comment was right on the money there for off-grid. So, let's say you've got a 10 kilowatt inverter. It can deliver 10 kilowatts of continuous power, and your home's using 4 or 5. Your headroom is only the difference. And so will your charger eat up that? So that you've got to be more cautious, whereas when on-grid, you have a lot more headroom capacity.
Okay. Are we seeing much of the VPP type products developing? This is really a question for Laura, I think. Are we seeing those products coming to market in Australia, even if they're not yet involving EVs necessarily?
There is a lot of them. I mean, there was the Tesla VPP product that's available in South Australia. a lot of some of the sort of the smaller, more agile retailers are offering products, particularly if you already have your own battery. So if you've got a reposit system on your battery, you can sign up to a few different retailers with that, and they'll provide you some value back to it in exchange for access to that system. So I think PowerShop, Diamond Energy have those products available. So yeah, they are becoming more common. Even sort of demand response, standard demand, behavioural demand response, they'll send you a message saying please reduce consumption now. You're beginning to see more of that too from some of these sort of retailers or some networks.
I could probably add to that, Laura, which is I do quite a bit of VPP testing here. So I've currently got the latest Fronius Gen 24 being VPP tested here. It really is almost like fairy dust that's being sprinkled on all storage systems now because of rebates. So in South Australia, the VPP incentive program, everyone's rushing to add that functionality to their product, often through a third party like Reposit or Switched In or other, who can aggregate lots of systems and provide that VPP functionality.
Yeah, and it's getting to the point now where some of these organisations are getting enough, so Reposits or those sort of organisations are getting enough resources under their control where they can begin to participate in the market in their own right, which they can do for frequency control services.
Okay, now we've had a few people asking about electric bicycles. Does that fall into your remit, Bryce, or do you want to pass it to someone else?
What's the question about electric bicycle?
Well,
I do own one, but it's been locked down. I haven't actually driven it or ridden it very
there you
much.
go. So they've covered on a few different things. One is, do you need special charging arrangements for it? Could you do solar on an electric bicycle? And what is the cost of charging and stuff? How do they work from a charging point of view?
I think of it as basically a slightly overblown mobile phone in a way. So if you can charge a mobile phone from a solar panel, you just need a slightly bigger solar panel, like a camping one would do it. It's because they plug into a power point and draw lower rates. I know there's several people on here, Rebecca, for instance, they could answer that more fully than I can, but it's basically a very low power draw. So an ordinary power point is only a couple of amps. So any little camping solar system would be fine. Might not quite fit on the back of a bicycle, but I'm sure there are people that have done it.
Okay, so I see some stuff coming up in the chat with lots of leads on where to get lots of information about this topic. So we probably leave that one there. We're just coming up towards the end. Is there any other burning questions that have come up? So many have been answered on the chat live in the Q&A page. I don't want to reiterate those because they're available for people to read. But if there's any last questions or any last comments, let's do perhaps a last wrap up from each of the speakers. Anything you would like to topic you'd like to cover or respond to from what's arisen in the discussion today? Start with you, Laura.
Oh, sorry.
That's all right.
Go the other, yeah. I was hoping other people would talk first so I could think of what to say. No, it's been certainly an interesting journey building these smart grid products in Australia so far, and I mean, as much as there is so much change happening at the moment, it's never been a more exciting time to be in the industry and be able to make some real change to make things better.
Excellent. Glenn.
Yeah, so look, a term I've been using a lot lately is the autonomous home. I guess we're moving towards that, where we've got renewable energy as a source, mostly solar, battery storage to get us through the night, EV to get us to transport or electric bike, add food systems and a passive solar home. Really, the home itself is energy autonomous, and it's becoming so doable, especially from a new build.
And Bryce.
I'll advertise a couple of events coming up. One's the 2020 EV Vision Conference coming up 27th of November. We're going to have 45 speakers, 3 streams, a lot of this sort of discussion about EVs and low carbon footprint and that type of thing, and policy will be bobbing up there. There's Tim Flannery is talking as our keynote. Anyway, you go to the website, I think that's in the listing there. And the other one is there's a Renew meeting, Melbourne Renew meeting, covering with Craig Rookcastle and a couple of other people, I think Wednesday 21st, and that will be basically covering again your carbon footprint, EVs, food and homes. So that'll be coming out to people's email boxes, I think, soon.
Now I'm just looking to see if Grant is there. Are you on? Yes, Grant, you're there. Grant, you're one of the people that was featured in the promotion for the event. You're the one of those who's been living a lifestyle. You've been heard this evening's discussion. Is there any points that you would like to add before we wrap up for the evening?
No, I think most people have covered it very well. The only thing is perhaps the interaction between all the different aspects of living with battery EV and the way that they fit together. But that's perhaps a discussion for another time.
Have you found it a satisfying journey yourself?
It's fabulous. And the fact that I'm a reformed petrol head and EVs are blindingly quick is a super advantage.
Very good. All right. Well, I think on that note, I might hand it back to our SHD hosts. And Sophie, if you'd like to wrap up.
Yeah, so I just want to thank you so much for tuning into this. This has been our last Sustainable House Day extension session of the series. If you enjoyed it, please be sure to check out the 170 homes featured on our Sustainable House Day website by visiting us at sustainablehouseday.com. You will also find virtual tour videos for many of the open homes this year and details of their sustainable features, including whether they have EVs. So this event, Sustainable House Day, has been organized by Renew. We're a not-for-profit that inspires, enables, and advocates for sustainable living in Australia. We also publish 2 magazines on sustainable technology in homes, Renew Magazine and Sanctuary Magazine. And you can find more about us at Renew and become a member at renew.org.au. So just before closing, we'd like to acknowledge our sponsors and our Renew staff, the volunteers, and the interns who made this event possible. So thank you so much for everyone who participated and who attended, and you can feel free to leave the webinar now. Thanks so much.